Okay, so now we are doing some more of that curve behavior, as I promised before. This will be short, hopefully. The leading coefficient, just so you know, every time I use LC, I'm going to say that that's the leading coefficient, because leading coefficient is way too much to write. All right, so the other day in the video, we talked about linear functions, and the degree is 1. So if my leading coefficient, which is my slope, remember, for linear functions, y equals mx plus b is our most common form of it. M is our leading coefficient. And so if m is positive, we know that we have, oh, I should use a different color. We know that we have a line that goes in this kind of direction. Doesn't matter where it is, we just know that that's a positive slope. And over here, when our leading coefficient is negative, we have a slope that goes like this. Our line goes like that. So top left to bottom right for the negative, and bottom left to top right for the positive. And that's important to keep in mind. All right, so quadratic functions, those are our x squareds. When a is positive, or when our leading coefficient is positive, remember we know that this function is going to open up. We don't know where it crosses the x-axis, we don't care. We just know that it opens up. And same way for when the leading coefficient, or when the a is negative, we know that it opens down. If you can remember those 4 things, you should be able to remember the rest of the graphs that I'm just about to tell you about, okay? Put little arrows on the end of these. All right, so cubics. When the leading coefficient is positive, when the leading coefficient is positive, I know it's going to act like this one. It's going to go from the bottom left to the top right. So it's going to go from the bottom left to the top right. And so it's a cubic, so I know it has the possibility of crossing 3 times. It might not actually cross 3 times, but I know that that's what happens. And then similarly, when the leading coefficient is negative, it's going to start in the top left and go down to the bottom right. So when my leading coefficient is negative, I know that it has to start up here, and then it has to finish down here, just like the line. Okay? So that also works for my 5th degree. Okay? If it's positive, it's going to start down here and end up here when my leading coefficient is positive. So it's going to go 1, 2, 3, 4, 5. Okay, now it may not do all of those, but that's the basic idea. And over here, when my leading coefficient is negative, I know that it has to start in the top left and go down to the bottom right. So it's going to start, so 1, 2, 3, 4, 5. And it's going to go like this. Kind of is the idea. Notice, just like the line, when I had a positive slope, it went like this. When I had a negative slope, it went like that. So kind of keep that in mind. Okay, when I had a quartic, which is, oh, why does that say degree 1? This should say degree 4. Degree 4, not degree 1. Okay, so when the leading coefficient is positive, it's going to open up. So it's going to go 1, 2, 3, 4, and it's going to look like this. Just like my quadratic, which is degree 2 even, it's going to do the same thing. And then when my leading coefficient is negative, I know it has to open down. So it's going to go 1, 2, 3, 4. I'm counting the number of times it crosses the x-axis. So that's my degree of 4. All right. So to summarize, and this really is the important stuff out of all these last 2 videos, if I have an odd degree, and my leading coefficient is positive, then I know it has to start down here and end up here. Odd is opposite, opposite corners. Odd, opposite corners. So I don't know what it does in between, so sometimes we do this, but we know that it has to then cross, over here. It's got to have at least one real root when we have odd degrees, because imaginaries always come in pairs. So over here with this one, when my leading coefficient is negative, it has to start in the top left and end in the bottom right. I don't know what it does in between, so sometimes we just draw squigglies and then we end up back down here. The squigglies just represent, whatever it's doing in the middle. Okay, so just like the linear, all right, when we do even degrees, okay, if the leading coefficient is positive, that means it opens up. They're going to start and end. It's going to open up. So it's going to start and end up here in the top two. So again, we don't know exactly what it does here, but we know that it's going to start and end going up. It's got to open up, just like a quadratic. And then over here, the leading coefficient is negative. It's going to open down. So that means it's going to start and end down at the bottom. And it's going to go, it's going to do its thing. We don't know what it does. And then it's going to end up coming down. Okay? So that's it in a nutshell. These two bits with odd and even, make sure you can identify just by looking at them. You should be able to identify. In the next video, we'll talk about multiplicity and when the graph is tangent to the curve and when it crosses the curve at a particular zero. All right, hope you're having fun. Bye.